So for this next part, we are still looking at slope, but this is going to be slope from 2 points. We have the slope equation m equals y2 minus y1 over x2 minus x1. So it's important to note that the y's are on the top of this equation, which the y represents your rise, so it makes sense that they are in that location. Your x's are on the bottom, x represents the run. So to find the slope between two given points, if I look at part A, we want to go through and label these so that we have our x1s and y1s and x2s and y2s. So typically the first point, I name my x1, y1, and the second point x2, y2. It doesn't matter which point you let be your sub 1s and which point you let be your sub 2s. It's just important that you don't mix and match them. So wherever the x sub 1 is, its ordered pair has to be the y sub 1. The same with the x2 and the y2. So using the way that I set these up, my slope is going to equal my y2, which in this case is an 11. Then I'm going to put down a subtract because there is a subtract in the equation for slope. And then I'm going to list my y1, which is a negative 6. And we will do something with the minus the negative here in a moment. On the bottom, I'm going to start off with the x2, which is a negative 6. And then I'm going to be subtracting my x1, which in this case is a positive 1. So this is our setup, and now all we have to do is simplify. So if you look at this, on the top, I have 11 minus negative 6. Anytime you have minus a negative, that is going to change to addition. There is no more negative left in between those two problems. It's like those two negative signs kind of fuse together to form an addition, to form that plus. So we have 11, let me change my color back here. 11 plus 6 now, which is going to give us a positive 17. And in the denominator, notice this is not the same case as what was happening in the numerator because the negatives are not right next to each other. So we have negative 6 minus 1, which is going to give us a negative 7. Always check your fraction to see if it reduces. This is 17 over negative 7. 17 and 7 are actually both prime, so their only factors are 1 in themselves. So there is no number that I can divide these by. And I don't have a double negative in my problem. I only have a single negative, which just happens to be in the bottom here. So this would be my final answer. This is either 17 over negative 7 or negative 17 over 7. It doesn't really matter where you put that negative sign as long as it only appears once in the question. Part B. This one has something a little bit different going on about it, which you'll see here in a moment. So again, I'm going to let my first point be my x1, y1, and then the second point is going to be my x2, y2. So I'm going to set up my slope equation, m equals my y2 of 17 minus my y1 of 17 over my x2 of 14 minus my x1 of negative 18. So notice I have that minus and negative again. So those are going to change again to an addition sign. So on the top, 17 minus 17 is a 0. On the bottom, 14 plus 18 is going to give us a 32. So again, this is a unique situation because you have 0 in your answer, but it is going to change, or your final result is going to change depending on where that 0 occurs. For this problem, the 0 is in the numerator. Anytime the 0 is in the top of your fraction, it is going to equal 0. 0 divided by any number, except for 0, is 0. Lines that have a slope of 0 are horizontal. They're going to go straight across. And their equations are y equals some number. So this could be y equals 4, y equals negative 2, or actually in this case, it's y equals 17, because both of the y values in the points are 17. So there is another situation that you look at this with. If we had flipped this and say the 0 was on the bottom instead of the top, this would actually give us an undefined slope. And undefined slopes are vertical lines, and they are x equals number equations. And that's important to remember for later on. So our next video is going to